Hi everyone, welcome to this Repro Rehab video. Today we'll be going through a really quick Python crash course using VS Code. My name is Michelle and I'm a PhD student at McMaster University. This video is for those of you who may have never programmed before and want a place to start, or for those of you who might already know some programming in R or a different language and may want to draw some parallels in Python instead. Whatever your case may be, let's get started. So we'll go over what today will look like. The first thing we'll talk about is what is VS Code and why would we use it. Next, I'll go over quickly why would we want to learn Python specifically. And for those of you who may never have programmed before, we're going to take a step back and talk about how to approach programming for the first time. And then I'll leave you with some examples and helpful functions in Python. So why would we use VS Code? Currently, VS Code is one of the most popular and powerful developer tools. There are a lot of industry partners that currently use VS Code, and it's a very big cross-platform, lightweight text editor that has a lot of built-in functions such as debugging tools. There's a lot of different extensions and languages that are supported by VS Code, as well as source control with Git and GitHub. So if you take a look at the right-hand panel of the page, we see on the top there's only a couple of the extensions and languages that I've included, but there's a lot more on the Visual Studio Code website that you can check out as well. Finally, they have a lot of different newsletters that are regularly giving you updates and talking about what's new. So in the most recent version of VS Code, we see in the bottom right picture, that's February 2024, so only about 2 months ago. And a very important and very interesting feature that this latest update has added is it's created a more accessible way to program using voice dictation in the editor. So how do I get started with VS Code? So the first step would be to install and open VS Code, and I know this might seem a little bit silly to begin with, but typically this is one of the biggest hurdles that I find a lot of individuals might have trouble with, is just to kind of get started and get the momentum going. So on the right-hand side, again, we have a screenshot from the VS Code website. So here they do have a step-by-step tutorial on how to get yourself situated and set up using VS Code. This QR code at the bottom too takes you to this exact site if you want to get started. The next step after installing VS Code would be to decide which language you want to use and which extensions and supporting programs you may choose to install from the language that you choose. So personally, and for today, we will be talking about Python. So the supporting program associated with that will be Anaconda. And the extension that we're going to install as well is Jupyter, because that's the IDE that I prefer to work in. So after that, you would just create a new file by setting up in an environment, and we'll take a look at how to do that a little bit later in this video. And once again, for those of you who may want to follow along, this QR code takes you to the website that walks you through the steps. So here's my pitch on why to learn Python. So Python is a really widely used and very versatile language. But one of my favorite things about Python is it's a very open source language, which kind of opens up the possibilities in terms of collaboration as well as the resources that are available to you. It's quite simple in terms of syntax, so it is relatively beginner friendly if you want to get started with programming. And in general, it is very helpful for data scientists and a larger coding community because of this open sourced nature and all of the resources that exist already. Now, if you are unfamiliar with coding, one of the biggest things to remember is that rarely is anyone doing anything from scratch nowadays. There's so many different available resources that you're able to pull upon, and one of the reasons that Python is my favorite language is that it is open source and there's a really supportive big community if you do get stuck. Building off of that, there's a lot of useful packages and different libraries that you may choose to use. And a lot of these libraries and packages are very suitable for things like data organization, visualization, and going beyond that into web developing, machine learning, and AI. And finally, it's a really useful skill to have. So it's very often used in industry, and this kind of makes it a really interesting skill to learn for both personal and professional reasons. So let's take a step back. For those of you who may never have programmed before or are very, very new to programming, let's break it down. So the first thing you're going to want to do is identify the problem or question you may have that you want to use programming to solve. So in our case, let's say you wanted to look at cardiovascular disease risk factors in older adults. Next, you would identify your approach to this analysis. So depending on what you want to do, for example, we want to set up data for running a regression. Let's take a look at what your data looks like. So in this case, let's say we have one large spreadsheet and there might be some missing data, there might be some unclean data that we have to work through, and we'll go through that a little bit later in the example. And the biggest step to do when you're approaching programming for the first time is writing out these steps for your plan. So that's something called pseudocode. This is basically writing code or writing steps of what you want to do, but just in plain English, and then figuring out the corresponding functions and corresponding steps in actual code after the fact. So we're going to go over that a little bit more on the next slide, but before you get started and before you even touch anything, it's also really helpliful to search up these useful libraries and packages that we were talking about a little bit earlier. So for example, libraries such as Matplotlib, scikit-learn, Pandas, and Seaborn are all very widely used packages that have a lot of documentation and have a lot of support that you can get started with. So let's revisit pseudocode. The first thing you want to do is kind of identify which packages you need. So for example, if I only wanted to do some kind of data visualization, maybe I will only need Seaborn, which is a great package for visualization. Maybe you want to analyze really big data and want to work with really large data frames. And in this case, you might want to install something like NumPy or Pandas. So depending on what your goal is, there will be multiple packages that you may choose to install. After you install and look at what packages you need, the next step would be to read in your data. So what that means is taking that spreadsheet that we have at the very beginning we were talking about and loading that into the program so that the program can take a look at what your data looks like. After that, you want to check what your data looks like. So you want to make sure that everything went well with this import. You want to make sure that your data looks like what you expect it to look like. So you always want to inspect your data to make sure that everything is there and everything is in the right order and what you expected it to be. The next step is kind of similar to the previous step, where you would check the formatting of your data. So what I mean by this is sometimes you have your participant ID, let's say, as a row instead of a column. And depending on what you want to do with your analysis, you would want to reformat your data. Typically, reformat your tabular data in order to align how your code works with how your spreadsheet looks like. Then, and this is not always necessary, but it's great to create a data dictionary. So sometimes when we load in our data, or when we are collecting our data to begin with, we'll name variables random names, or we might save something and name it something random, even though this isn't great practice. It's always great to create a neat data dictionary that says what each variable you're looking at is doing. If there's a code or a subcode with a variable, maybe you want to take note of that too. So for example, in a couple of the data sets I've worked with, there are things like asking whether or not you're a smoker, and instead of yes or no, they would have 1 or 2 or 0 or 1 in order to define the yes or no. And so your data dictionary would kind of cover that, and just make sure that all of your variables are there and you know what each variable means. Another couple of things you may choose to do is create composite variables. So this would mean maybe a cardiovascular risk score that you can create with the data that you currently have. So maybe that takes in something like smoking and age and sex and stuff like that. So a composite variable is something that you can create. You might choose to do filtering variables. So sometimes if you want to do sub-analyses and only want to include, for example, the postmenopausal women, then you might choose to create a filtering variable where for this analysis specifically, you call upon this variable so that only postmenopausal women are being analyzed. It's kind of similar to what subsets also do. So you might choose to create sub data frames that have the specific variables that you want, or that have that meet certain criteria that you've predetermined. And then functions are things that you can create as well. So if you wanted to do an action repeatedly, or have a lot of steps in order to achieve a certain thing, so such as maybe creating your own figure, and you want it to look a specific type of way and you need to apply it to multiple variables, you could create a function for that so that you can call upon your own function later on in your own code. And one of the biggest concerns that I've heard and I also encounter is, how do you know if what you're doing is actually doing what you want it to do? And that's why you're going to do a lot of sanity checks whenever you're working with data. So whether that means visualizing it every step that you take, or just double checking that the first couple of rows look like what you want it to look like. Sanity checks are a really important and really great way to make sure that you're on the right track at all times. So with that being said, we're going to move to VS Code, and we'll take a look at my workspace, and we'll take a look at a couple of functions and how to get started in Python. So this is what my VS Code looks like. Currently, I have a piece of code open that I've created for this tutorial. This code you can see is called VS Code Tutorial Reaper Rehab, and that's what I have open right now. Typically, when you first open it, they'll have a newsletter ready and talking about the latest updates. So if you think back to one of my first slides about the recent update in February 2024, you have a newsletter like that when you first open VS Code. You're also sometimes prompted to use or to link a Git repository. So sometimes you'll see a notification come up in the bottom right that asks you, a Git repository has been detected. Do you want to link to this, or do you want to work within this? So for our purposes, we will just look at this piece of code. So you notice in this corner here, we have the latest version of Python that we're working under. If you were to create a new workspace, you would go in to the command palette, as we were talking about earlier. And once you do create a new workspace, you're able to choose what base you want to be working in. You're also able to work in other languages as well, but for today's purposes, we will just talk about Python. In order to import or add extensions, you can go to the leftmost corner of the screen. So you can see I have a couple of extensions open, including Jupyter, Python, etc. You can search up whatever you want to be doing and install these packages here. There's a couple of other different icons on the left. The VS Code tutorial on the website that I linked is a really great starting point to explaining some of these, but for today's purposes, we will just focus on what I have open now. So, as you can see here, this is my current workspace. This is the code that we're currently looking at, and I also have a mock data set that we might read in a little bit later. So, let's get back to this. So in today's tutorial, as it says, we'll go over a couple of basics of programming using Python. So the first step that you may remember from the PowerPoint is identifying which packages that you need. So here I have a couple of packages in this code chunk that I typically use, and if you want to pause and take a look at what each library that we're importing does, you can do that. But what I'm going to do is go ahead and load that. You can see that was a very quick load as well. So a couple of the things that I'm loading in include certain things that we've talked about earlier, so things like NumPy, Matplotlib, Pandas, Seaborn. These are all things that you'll see pretty frequently when you're working in Python. So the next thing I wanted to do kind of strays from the presentation a little bit, but I wanted to show you how VS Code specifically helps with troubleshooting errors. So first, we'll see in this code chunk, I just wrote plain English language, and you see that it's not gonna turn out as anything. So let's run that. It'll tell you that the syntax is invalid, and sometimes if you hover over certain things, it'll try to give you some recommendations for how to fix that. So you can see all of these yellow and red squiggles are things that I did not do correctly. Another problem is, for example, if something is incorrectly loaded or missing, so something that I'm trying to do with this code chunk is just generating a random integer between 0 and 70. So if we go ahead and run that, it'll give us this name error. So name random, which is the library that I was trying to pull from, is not defined. So you can see here what it's going to recommend is add import random. So we have that up here. I'll run that again. And now a number between 0 and 70 is generated for us. So these are only a couple of the ways that VS Code is able to kind of help you debug and identify your problem and try to help troubleshoot your errors. So getting back to the tutorial, the first step we're going to want to do after loading our packages is read in our data. So if you remember, I set up my own local repository here, own local directory here, where my mock data is what I want to read in. Here we have a variable that I define for this mock data, so I'm calling it the raw data frame, or raw df. And this is the line of code that I would use to read in an Excel file. So if you see here, XLSX is the suffix, so that's an Excel file. So I have pd read Excel and the file name that I'm working with. So because it's in the same folder, there's no file path on my computer that I have to add in, and we'll just load that. So this data frame, or this data set, has been loaded in. The first thing that I'm going to do is just check it, just to check to make sure if there's even values in this data frame, if there's anything looking wrong, if it imported kind of wonky. So these are the three different prompts that I like to use. This first one gives you a summary table of your entire data set. Head gives you the first 5 rows by default, so if you wanted the first 10 rows, you can add that in, but it gives you the first 5 rows by default of your data set, and shape gives you the number of rows and columns in your data set. So we're going to run that, and we'll see in this descriptive table, we have a bunch of descriptors here, as well as all of the variable names on the in the first row. So as you can see here, I've created this mock data set with a bunch of different variables, not all of which are relevant, so that'll come into play a little bit later. For head, we see the first 10 rows, so entries 0 through 4, and we're able to take a look at what these first 5 people look like. And shape, we have the number of rows and the number of columns here. Another step we want to do before getting into anything else is kind of understanding and making sure our data looks right. So if you remember in our presentation earlier, we want to kind of understand, check the formatting of the data, and then create a data dictionary. So as you can see above, I have things called entity ID, tree thickness, activity, hot dogs consumed, and they're all kind of in a different format, and this doesn't look really good. It doesn't look very clean. And not all of these variables are even relevant to us. So what these first 2 lines of code are doing is the first one is identifying the specific variables that I actually care about. So in our case, unfortunately, the number of hot dogs consumed is not relevant to our research question. And so the variables that are relevant are listed in this first row, exactly how they appear in your data set. And the variable descriptions, or a better variable name, is the second row. So I've switched entity ID into just ID. BMI column is now just BMI. Menop is now menopause. And so these are a lot more helpful in allowing us and maybe other collaborators to understand what this data is actually telling us. This third line of code is taking this raw data frame and adding a subset so that we never have to manipulate the raw data. This raw subset is taking a copy of this raw data and only isolating the variables that we identified as being important. And then after we have that data set, we're going to rename the columns using the variable descriptions. After we do anything, we want to check that we made sure, check to make sure that we did the right thing. So as you can see here, I have head and describe again. These are just the 2 ways that I like to look at the data. So we'll run this chunk of code and see what happens. So we see here, this is the product of df subset head. We see the first 5 lines and it's looking good. We do have all the renamed variable names on the first row here. And then here we have describe. So a couple things that I really like to look at are count. So here we notice that 3 people have age missing versus another 3 people also have BMI missing. Sometimes looking at things like min and max are also really important. So we know that hand OA is going to be a variable that looks like this. So here we have zeros and we do have ones, but it's not shown here. And we see in hand OA there's also a -8. So in this case, because I know the data set, I know that -8 means that the data is actually not there, or this variable was not properly collected, and we have to drop this data set. Drop this specific individual for hand OA. So this is a really good way to kind of look at a quick summary snapshot of your table. There's a lot of different ways of reshaping and pivoting your table. So for example, if I wanted to pivot the table based on the on ID using the columns menopause, I'll do that, and you can see that in my head and my describe, the menopause variable is now kind of a descriptor row here, and all the variables are presented in this way now. There's also a lot of different ways to combine your data set. So for example, if you had this subset and you wanted to concatenate or merge or append a different data set to it, to kind of maybe harmonize your data or just to add in a new variable, what you can do is the following. So you can either create a new data frame in order to merge. So what I've done here is I created a data frame called new variables, and in this data frame I've just put entity ID and sit to stand. So this STS is sit to stand. Combining data frame is the new name that I'm creating for this new data frame, because I never want to rename or overwrite a line of code that I might have done before. So I always find that making a new data frame that has a descriptive title is really helpful. So now we see that in combining data frame, it's actually the raw data frame that we're never going to touch, plus the new variables. So in this case, the new variables are entity ID and sit to stand. Now again, this is another way that you can rename your columns. So we're going to do rename columns. Entity ID is going to be renamed to ID. Then we're going to see if we actually did what we intended to do. So we see here 500 people with ID and 500 people with the sit to stand data. So this is the new data frame that we've created to merge. And if we wanted to concatenate it with the original data, but not the raw data, what we can do is create a new data frame called concatdf in order to concatenate this. And here we're going to use the pandas library and concatenate the subset that we created earlier, as well as the combining df, which is what is shown above. And once again, after doing anything, I like to do head and describe, just to make sure that the variables that I actually want to include are there. So what we see here now is we see that after menopause, sit to stand has indeed been added. Now don't be deterred by all of these nans in my data set. I've included a bunch of blank cells just to show you a little bit later how to check for nans. But you can see here there's an additional variable now, but there's not two IDs because we've identified the participant ID as where to add it. Another way we can do this is merge the data frames. So what we have here is the merged DF is the subset that we've created earlier with the combining data frame. And here we're going to merge it on ID so that once again, ID is not going to be there twice. And once again, we're going to do a sanity check to make sure what we're doing is indeed what we're trying to do. So here we are. We see sit to stand ID. So something I was talking about a little bit earlier is checking for nans. So there's a couple of ways that we can take a look at whether or not our data has nans or just not a number, which essentially means that it's a blank cell. These are two ways. Actually, this is just one way that we can do it. These are all a couple of ways that you can identify whether the cell you are looking at has data in it or not. So we'll run this. and it'll show us in the raw data frame, these are all of the variables that we have, and over here we see the number of missing variables in that data set. Again, when we isolated our subset, here we are, and in our subset we have also the number of people who are missing certain variables. So if you remember, menopause had a lot of NANs, and that's because 481 participants did not go through menopause and had blank cells. So something I've included here are, there's a couple steps you can do depending on how big your data set is. Sometimes you might just choose to drop the people who don't have the certain variable and exclude those people in your final analysis. There's also different ways that you might use imputation techniques to kind of fill those variables. That's something that I won't be discussing further, but you're definitely welcome to take a look. I've linked a source that you might find interesting to look at imputing missing data. Okay, we are nearing the end of this tutorial. This markdown chunk here is drawing a couple parallels from some existing R functions that people might find interesting to do in Python instead. So depending on what you want to do, for example, reordering the rows, picking a variable name, picking a variable by their name, grouping data, etc. These are a couple keywords that might be helpful in showing you what to do in Python instead. We're going to do a really quick, ignore that for now, a really quick visualization here. So we see here I'm using SNS, which is the shorthand that I've imported for Seaborn, which is a visualization library. And what we're going to plot here is age on the x-axis and activity on the y-axis. And I kind of want to see sex differences here. So I want to split the colors by sex. The data we're pulling from is the subset that we created. So we're going to go ahead and run this. And this is a very crude example, but this is what the figure looks like. So you can see it's grouped by sex, and we have age and activity. So if this is something that you're interested in terms of using VS Code, there's also a lot of different text editors that you might choose to look at. So here I've linked a source that takes a look at a couple existing text editors and comparing them to each other depending on what you want to be doing. And then a link and a couple of points about VS Code for developers here. There's a lot of different text and code editors. There's a lot of different people who also prefer just to use things like Spyder or R, the R console and stuff like that. So if that's you, that's totally fine. You don't have to use VS Code. You never have to use Python. Hopefully this was just an example for you to maybe get started and see why you might benefit from using Python. So the final thing I'll leave with you for this VS Code tutorial is I've pasted a picture of my cat. I did not know that these are how images are coded, so I thought that was really interesting. So I'm going to go ahead and run this, and you can see this little gremlin here.